Hello and welcome to the Theory of Computation lectures. In this class, we will discuss a problem on Epsilon NFA to NFA conversion. So, let us say we have this Epsilon NFA. You can see there is an Epsilon transition from state A to state C. So, we are going to convert this to its equivalent NFA. So, we know what the process is. The first step is to find the Epsilon closure of each state. So, let's find out the Epsilon closure of states A, B and C. So what is the Epsilon closure of state A? Where all we can go from state A for free. As you know that any state has itself in its Epsilon closure. So state A to state A can be transitioned for free, and also state A to state C can be transitioned for free. Can we go from state A to state B for free? You see this edge has 1, right, as the input symbol. So from state A to state B we have to get a input symbol 1. So it cannot be a free transition. So basically the Epsilon closure of state A contains state A and state C. What about state B? Okay, state B will contain itself in its Epsilon closure, but there is no other state we can go to for free from state B. So basically the Epsilon closure of state B contains state B itself. Similarly for state C, the Epsilon closure contains only state C. Now, for each state, we have to find out the reachable states for every input symbol. Again, how do we go about it? So basically in our NFA, we have 3 states. We have seen in the previous example also that the number of states do not change. Neither do input symbols change. So we will have the same input symbol 0 and 1. What will change is the transition rules and also the final states. So for this NFA, if the input symbol is 0 and the current state is A, what will be the transitions? Let's see. So from state A on Epsilon closure, we can go to states A and C for free. Now from state A on input symbol 0, we can go to no other state. But from state C on input symbol 0, we can go to state A. Now what is the Epsilon closure again of state A? That means which are the states that we can go for free from state A? That is the Epsilon closure of state A, which is states A and C. So on the NFA, if the current state is A and the input symbol is 0, the next state will be state A and state C. Similarly, if you want to find out from state A where all we can go by input symbol 1, so first find out the Epsilon closure of A, which is A and C. On A, input symbol 1 takes us to state B. On C, there is no transition on input symbol 1. So basically we have to find out the Epsilon closure of B, which is state B itself. So the NFA will transition to state B if the current state is A and the input symbol is 1. Okay, now let's look at state B. On Epsilon closure of state B, we can go to state B itself. Now what if we are given input 0 at this state? So in state B, if we are given input 0, we can go to states B and state C. So we have to find out both the Epsilon closures of state B and state C, which is again states B and C. As you can see from here, the Epsilon closure of state B is state B and Epsilon closure of state C is state C itself. So the NFA will transition to states B and C if the current state is B and the input symbol is 0. So what if the current state is B and the input symbol is 1? Again find out the Epsilon closure of B, which is state B itself. And then from B on input symbol 1, we can go to state C. From C, the Epsilon closure takes us to state C itself. So basically from state B on input symbol 1, the NFA will transition to state C. Next is to find out the transitions for state C. The Epsilon closure of state C is C itself. On C, if we get an input symbol 0, we go to state A. The Epsilon closure of state A is states A and C. So on C with input symbol 0, we can go to states A and C in the equivalent NFA. Again on C with input symbol 1, where all we can go to. Find that out, firstly we see from C where we can go for free, which is to state C itself. Then on 1 there is no transition, so basically we go to state phi, and the Epsilon closure of phi is also state phi. So basically from state C with input symbol 1, we will go to the phi state. Now the final step is to draw the state transition diagram of the NFA, making all those states final whose Epsilon closure contains the final state of the Epsilon NFA. So what is the final state of the Epsilon NFA? That is state A. And which are the states whose epsilon closure contains that state, it's only state A. So in the equivalent NFA again, only state A will be the final state. So let's make it the final state, and then on state A, if we get input symbol 0, we are going to remain there, and if we get input symbol 0, we can also go to state C. If we get input symbol 1 on state A, we go to state B. On state B, if we get 0, we can remain in state B or go to state C, and if we get input 1, also we will go to state C. On state C, if we get 0, we can either remain in C or go back to A, and if we get 1, we will go to state 5. So that is the design of the equivalent NFA of this Epsilon NFA. In the next class, we will look at another problem and see how we can convert Epsilon NFAs to NFAs. Thank you.